Welcome to 2017, question C-2, it's the structural forms question. The image on the right shows a sun canopy over an umpire's chair in a tennis tournament. Okay? The canopy is based on a hyperbolic paraboloid. The projections of the canopy are shown here in figure C2. Here are projections, as well as the pictorial view. The surface of the hyperbolic paraboloid is generated by translating parabola ABC. So here's our parabola ABC. I can see it here. And it's being translated in a vertical position along parabola DBE. So it's being translated along that. So if you imagine it's curved there, kind of facing towards us, and that is traveling along like that with that parabolic shape. B is the vertex of both parabolas. Okay, so B here and B here are both the vertices of those. Draw the given plan of the canopy showing all points of tangency. Okay, so we want to draw our plan view here. Okay, so looking, we've got a scale of 1 is to 5, so every measurement here we need to divide by 5. So that will become 1400, that will become 14, 0, 35, 35, 30, 140, and 40. That is it. We do not divide the degrees for there. So then when I come down, draw our XY line first of all. So XY line. Okay, and we'll come down. I'll just keep that there so you can see it clearly. So 140, so I need to come to the center just to find that axis there, or the center line. Come down maybe 85. Okay, so that's point D, and start measuring off and finding some of these points. So we've got 35 to the center of that circle. We've got another 140. And then another 35. So that finds point E. A and C, they'll be in the middle. Let's just double check the length of everything there. So halfway, we'll draw a vertical line, and A is going to be 70 up, and C was 70 down. So 70 up to A, 70 down to C. A, C. Right, so let's draw our circles. So I've got radius 35. On the followed by E as well. And then my radius for A is from the center out to A. That's going to be my radius. Okay, and to find a tangent, we want to go 60 degrees and 90 degrees flat, so that's going to be 30. Just prove that, just to show a point of contact between all of those. I'm not sure is the marks actually going here for finding the exact point of contact, but there's no harm in showing. So that's the outline of the plan completed. Showing all points of tangency, so same thing, point of contact. 90 degrees, 90 degrees. For all of those. Okay. So we found all our points of contact there. Now, draw the end view of the generating parabola ABC. So let's project up from our plan to our end view. Y line and project up to my end view, project up to my end view for E or B, and project up to my end view for C. Right, and my heights then. B is up a height of 150, which is 30, and then 40 up further to find A and C. So let's go up with 30 and a further 40. So A, B, C. So let's draw our tangent now, or our parabola, excuse me. So a line at any angle, start off, go 4 times, 4 equal distances. So 1, 2, 3, 4. Join that back. So the lines running parallel to the axis. Okay, and next we're going to divide up this side into equal parts. So step off, divide this into 4, let's divide this side into 4 also. So 1, 2, 3, 4. Okay, excuse the shadow kind of there. Let's join the last point to C. Parallel lines. Now, all of these divisions join to our vertex. We got 1 point, 2 points, 3 points. We'll draw the freehand curve in a second. I'm just going to project across through axial symmetry to find the mirror of that, or the symmetrical side of that. So 1 point, that is our that's the projections of our parabola. Okay, it's in a dashed line here, so I'll just show the same in my solution as what's shown in the end elevation given the question. Okay, so end view completed. Project the front elevation of the canopy. Okay, so we want to first off draw our DBE, that parabola DBE, and then we'll talk about finding points along this curve. We should be able to find AC also. Yeah, we can find AC. So parabola DBE and point C, AC. So it's AC. This is point B. And we can find E on the ground, D on the ground. Okay, so same as before, we want to divide our divide it up. Actually, can we do this without the construction? That's 105. So 105 divided by 6 equals . So this is 30 high, so I divide that by 5, I get 666. This is 105. If I divide 105 by 5, I get 21. So let's do that. Now if you want to, you can do the construction again, but just to save time in this video, I'm going to do that. So got 21, 42, 63, 84, and 5. And going vertically then, we'll go in 6, 6, 12, 18, 24. Okay. Drawing these ones back to the vertex. Got points. Let's project them across using our axial symmetry. Okay, so that saves us a little bit of time there. Could be valuable in the exam. You might even, using the measurement there, being able to do something similar. So here's my curve. Great. Okay, so what we're going to do next in order to complete this is if we take the vertical sections, okay, so every vertical section, and I've given us kind of a tip here in that graphic, every vertical section gives us an identical parabola. Okay, one that's identical to ABC. The only other difference is the height of it. Okay, so if I take the vertical section here, if I locate the width, I can find the width here, and that will give me a height, which I can use then to step off of DBE. Okay, so let's take a couple of vertical sections on 1, 2, 3, 4. Could even use these. Yeah, I'll use these for these 5 positions. Okay, so I've got vertical section there, section there, okay. So we'll start with the smallest one and work our way through. So I'll project. I have an option. I can either take that height and step it off there, or I can project it. I'll take the height. I'll keep it kind of cleaner. So I'll take the width. Excuse me. So that distance. Step it off. Okay, so that locates me a height. I can take that height and from that corresponding section I can step that off there. I actually want to show these in this position as well, because it's going to be a corresponding height, because it's 5 divisions, same as what we've got on the left hand side. So get that height, stick it off there. Okay, now I get my next width. Drop that down. Find the new height. So that height I can now step off of here and here. Stand these up. Okay. Another width, stepped off, so it's getting repetitive. Drop that down, stand it over to find the height. So that's the height I'll use there. The last one then. With showing an elevation or end elevation, drop it onto the curve, find the height from B, back to my section, there. So I've got my freehand curve. Okay, so that is the front view of the canopy completed also. Lastly then, it has been decided to extend the surface of the canopy to provide more shade for the umpire. This will be achieved by extending the generating parabola ABC upwards and outwards as indicated by the arrows in the end view to a width of 900 millimeters. So it's 700 millimeters at the moment. They want to extend it out to a width of 900. So basically make that a larger parabola. On a separate diagram, draw the new end view of the extended parabola. So we're going to draw that parabola all over again, down here to the left. Just move, shoot that. So, parabola I was dealing with originally. Hang on. We have a 700, which was 140. And it was a height of 40. Okay, so now when I redraw that parabola ABC, C. To make this quicker, I'm going to use those divisions. Yeah, use those divisions because it's identical to what I want to do. So let's get one of those. Let's stick it once, twice, 3 times, and that equals to the 4th. And then we'll get length on the side, once, twice, 3 times, and it's equal to the 4th. So again, this identical parabola. They're a little bit tedious here because I've done this all before, but I suppose the positive is we're getting marks for all of this. And it's not asking us anything new just yet. So we've got there. Mirror that across, or axial symmetry across. So distance. Okay, so here is a parabola in its current size. Okay, well what they're asking us then is to increase the size of this from 700 to 900. That if we were to convert that 900 is 180, so that's 20 out left, 20 to the right, so that's 20 left, 20 right. Okay, so we want to project this out until it hits, or find points on this curve until it hits this line going up. Okay, so we have already completed some of the construction. So if I actually do that, and if I, similar to what I did before, get that distance, step it off, do a couple of times. From B, so we're radiating out now. It's like an enlargement to find points out along here. So because I've got those distances, I now need to get my distances that I stepped off horizontally here. So that's 1 and 2. That's from there, and there. Okay, because we have to go beyond that 900 width to find exactly where the path is going to go. So here we have it. Okay, and we'll mirror that across. Bring that right to there. Point shown there, and we've already found the finishing point, so we can extend. So, okay, so that is the completion. Double check. The width of 900, that's completed there. Set diagram, new end view of the extended shadow, which is that completed. So, here we have the solution there to the solution to 2013 structural forms questions, question C2, if you chose that on the day of the exam.